jump back to the inverse function, give you a little discussion and see what this is all about. Now, I will tell you, by previous classes, I think of all topics, we've had more concerns about inverse functions. You'll see why when I get into it, okay? And then I'm thinking we'll move into chapter 6, and I do think I have 4 handouts, looks like it's right here, to give you, that goes through 6.1, 6.2, 6.3, 6.4, and all the way up to 6.6. If I get through all this, chapter 6 is almost done. And then I'm ready for chapter 7. I'll see you next time. Okay? We'll see what happens. Arena, since you're close by, I think this discussion was brief. There's this. And you guys had an inverse on the last test. Of course, we know the notation. Jude, I think in the higher math classes, they may call this ARC, A-R-C, rather than inverse.
I think we just use it interchangeably.
Yeah, exactly. But were they using more arc rather than saying inverse? Were they using this notation here? Or were they saying arc sign, arc cosine?
I think we write it like that, but read it out arc sign.
As arc. Okay, so guys always do that up to you. When you go to math 7, we'll call this arc because it's an arc circle involved here. For us though, it's inverse. Okay? There's my notation. Now, before I jump in and give you some restrictions here, so watch out for it. Please tell me, let's start with number 1. Anyone recall anything at all in our discussion about an inverse in the past? Joseph? What you see there, that you recall about inverse?
Has to be 1 to 1.
It's gotta be 1 to 1, that's the most critical one, I think. It has to be 1 to 1. Oh, you guys are gonna put on the side here, in terms of a graph, it's gotta pass this. Horizontal line test. Not the vertical line test, that's for a function. Horizontal line test, to see whether or not it has an inverse. Is it 1 to 1? Does anyone recall anything else that may be helpful? Because we've had a discussion on inverses before. That may help me when I move into now inverses of the trig functions. Anything else that we should realize at this point? Look at bragging on you guys. You're bragging on you. Okay, so again. Love that. When you form the composite, here we go. You got this on the last test. What are you supposed to get? X. That's like a little check. Is that true? By the way, I should, since you're going to be leaving me, I should point out just in case in calculus the professor writes it in this order, same thing. Should work both ways. Number 3, something else. Yes?
The domain and range argument.
Thank you. The domain of the inverse, all right, like that, should be equivalent to the range of the original. And the range of the inverse should be equivalent to what? The domain of the original. That's critical. And that might be, unless someone come up with something else, does anyone think they know something else? Yes?
The x and y intercepts also fit, right?
Yeah, everything flips, everything interchanges. You know what, maybe I should point out first thing, this word. What you just said there is definitely true. It's all about interchanging. The x-intercept turns into the y-intercept, and vice versa. All that going on. Guys, can anyone recall anything else? I think those are the principal ones. Unless someone can remember something else maybe. Okay? Now I got to apply this on the trig functions. Now here's the issue. And I know we saw this just for an introductory discussion. Pardon me here. At into class yesterday. If you're given this function, we'll start with sign. And we know the graph. My goodness, we know the graph by now of these trig functions. Guys, this one is one that looks like a wave. And we know where it starts, where it ends for one cycle. 0, pi over 2, pi, 3, pi over 2, 2 pi. Goes up to 1, down to a negative 1. Now that graph itself, for sine, starts here. Goes up to 1 here at 90. 180 is here. 3 pi over 2, 270 is down to negative 1, and back to 0. It takes a shape something like this. Is that true, guys? We've seen that, of course. So that's one cycle of the sine graph. Now, in this discussion today, we want to find, not this, we know what this is. We want to find this. Exactly. And they use this notation. Okay, find the inverse. Let's go back and look at the previous discussion. To find that inverse, first, what my students gave me the very first condition was, Professor, I remember the function must be 1-to-1 to have an inverse. It must pass the horizontal line test. This graph, guys, in the red, does it pass the horizontal line test? No, so I would say as a student, Professor, this function has no inverse. You know what, I think I told you the story about a committee getting together, mathematicians and scientists and so forth and so on. I've heard that story before. And they created and made this 1-to-1. So I could find an inverse or have an inverse sign. And what they did, guys, we have to accept this. I'm not going to argue with the committee. They go out to a negative pi over 2 on the left, and they extend that red graph, as if we're drawing another cycle, on the left, like this. Right here. And I should label this as negative pi over 2. You guys will agree that negative 1? The graph says, and of course, the graph still is not 1-to-1, and the strange thing is, and I'll accept it. They tell me to accept it. They wipe this out. They look at that little slice. Now definitely, is that little slice 1-to-1? Would it pass the horizontal line test?
Yes.
And now it does have an inverse. But the trouble is, when they do that, my domain has been thrown off. I think the domain on the regular sine graph was what? Negative infinity through positive infinity. Is that true? This is it. So I have to first mention the domain and the range on this and the discussion here. Guys, on the side here, the discussion has been in red. Corresponds with the red graph. The domain and range of this slice. Let's get the domain out of the way first. How would you describe that little slice that they're asking us to accept? From left to right on the x-axis, it goes from what to what? What's the domain of this little slice? Negative pi over 2 over to what? I think this is pi over 2, wasn't it? So does it go from a negative pi over 2 to a positive pi over 2? That's my domain. That's it. Put a bracket. Not negative infinity through positive infinity. It's been cut off. The graph has been sliced. Range on this little red piece, the up and down, drops down to what? Negative 1, which I think the sine graph did also. And up to a what? Positive 1. You and I hate to use the word memorize, we gotta know this. Now that's the domain and the range of the slice that they're asking us to accept. Now PK, Now they're saying, well, accept this, this is a piece of the sine graph. But they're looking for inverse sine. So let's try to drop down here and now list the domain, I'm using black here, the domain of the inverse. Now what would you say based on what you see up here, what would it act as the domain of the inverse? To begin. And one of my students said this right here was critical. Should the domain of the inverse correspond with the range of the original? And what was the range of the original? Negative 1 to 1. That's now my domain of this. Things are being turned around here, interchanged. If I ask for the range of the inverse, with this statement, the range of the inverse corresponds with the domain of the original slice up there. And that was what? Negative pi over 2 up to positive pi over 2. And that's the way it works. And that's what I have to accept. I have to accept it in grad school. You have to accept it. That's mandated. That's what we do. And then those calculators have been programmed with this. When you look at that inverse sine key or inverse cosine key on the keyboard of a calculator somewhere or graphing device, it's been programmed with these conditions. And he said, Professor, it makes sense. I think, right, from the red to the black, they interchange. Now, where we have to be careful before we jump into some work here is, if you're asked to find, look at this, number 1, inverse sine, and inside here, I've put those for the 1. Now, inverse sine tells me for the domain, x is the domain, I may use any number inside here for the x domain, as long as it is here. It's got to be caught between negative 1 and a positive 1 inclusive. So can I place a 1 inside there for domain? Now, can anyone tell me, here's a translation. It says find inverse sine of 1, and there's going to be an answer. Domain is good. In your mind, you say, oh, he's asked me to go back to that unit circle and find the angle at which sine was 1. Can anyone recall where on the unit circle, sort of thinking backwards now, at what angle was the y coordinate, which is sine 1? Okay, pi over 2, 90 degrees. Does everyone agree? So that's the inverse sine term things right here. At pi over 2 on your unit circle, if you look at the y coordinate, you're at what? Now y coordinate is sine. And that's what they want. Now, I gotta be careful, now I'm being very careful here coming up. This answer coming out is the range. This is my domain, this is the range. The range of the inverse, here's, you have to be cautious. The range of the inverse, answer coming out, had better fit here, where you can accept it. Does pi over 2 fit the restriction here for the range on the inverse? Thank goodness it does, with that bracket, it says I can include it, and I'll accept it. No problem. Number 2. Let's write inverse sine 1/2. You check first though. I see a 1/2 pk inside there, that's my x, that's my domain. Am I allowed to use it? Is it caught here? As long as it's here. And 1/2 is caught in this interval, so I should get an answer. Now, can anyone think on the unit circle, where have you seen, at what angle, have you seen the y coordinate sine 1/2? I hear, I think I heard, what was it? Someone said, I think. I heard what, 30 degrees, which is what, pi over 6. Let me do this, because I see some looks like, uh-oh, I'm thinking backwards now on that unit circle. The reason it's pi over 6 at this point, guys, if you take sine of pi over 6, this is what it means, yes, you get 1/2. That's what it means. You go to pi over 6 on the unit circle, you'll get 1/2. We all know that. Now, this answer that came out, Gia, the answer came out at pi over 6. Please tell me, does it fall where it should fall? By restriction, does it fall between negative 90 and a positive 90? Think in terms of degrees, it may be easier. Negative 90 and a positive 90, where this, I think, is 30 degrees. So does 30 fall between negative 90 and a positive 90? in an integral? If so, I'll accept it. Should it fall, guys, does 30 fall between negative 90 and a positive 90? And I'll accept it. That's the answer. Next one. Number 3. Inverse sine negative 1/2. Someone tell me on the unit circle, where have you seen the y coordinate equal to a negative 1/2? Fourth quadrant for sure, do you remember the size of the angle? Oh, I heard 11 pi over what? 6? This is in black. Tell me, at this point, does someone recall another angle besides 11 pi over 6 whose y coordinate sine is also negative 1/2 besides 11 pi over 6? That's quadrant 4. I think there's one in quadrant 3. And what is it? I heard 7 pi over 6. Now you know we can't have two answers. These are supposed to be one and
We
one.
need to choose the one who falls
Wait,
between
wait,
the
wait.
lines.
What?
Because the lines decrease.
Yeah, but we can't have both answers.
We can.
So we're gonna,
So
it's not
we
one to
need
one.
choose one.
It's not one to one. So I can accept both answers. Now I'll have to pick one of these. And I said, Professor, how are you gonna choose which of those two? But first, I'm doing this in degrees, a little bit easier. I think this is 330 degrees. Does 330 fall within this restricted between negative 90 and positive 90? 330 does not fit. If you're on a number line, negative 90 to a positive 90, is 330 between those two? No, from a negative 90 to positive 90, so this one's out. Philip, I can't accept that. Maybe 7 pi over 6, which I think is 210 in degrees. Now, does 210 degrees fall between, it's got to fall here, between negative 90 and a positive 90? Think about a number line. Does 210 degrees fall between negative 90 and a positive 90? No. Are you kidding? And I'm going to say no answer? Okay, tell me again. Now, someone's being clever here, said, no, Professor, if I go to my graphing calculator, use a graphing device, and I press that inverse sine key, and I put in negative 1/2, an answer does flash on the screen. But that answer flashing on the screen is not this. It's not this. Because neither one of these fit this restriction. That's the hardest part about inverses. We've got restrictions. Now, I heard though, look at this. That 11 pi over 6 that a student gave me, what was that, 330 degrees in quadrant 4. You know it's here. Looks like this. The truth? I'm going to use degrees here. This is 330 degrees. That's 11 pi over 6. And one of my clever students, Selena, she said, Professor, if you are really searching for an answer, and some of these things will not have answers, but it looks like this one might, she said, think of that angle as looking like that.
Negative 30.
Terminates the same place. So why not think of 330 as going backwards how much?
Negative
30. So I can call this negative what? Pi over 6 or negative 30. And that's equivalent to this. And you're talking about the same angle except you moved it in the opposite direction. And prefix with a negative sign to show you did move in the opposite direction. Now guys, please tell me after that reasoning, this is negative 30. Would negative 30 fall between negative 90 and a positive 90? If so, we finally have an answer. It's got to fall here. And since it does, the final answer over here, after all that business there, not 11 pi over 6, 7 pi over 6, it is, I'm going to put it in red to show what it is. It's this. That's exactly what you would see on the screen of a calculator. And as a student, you may think, where did that number come from? Well, those people who program these calculators must be smart. And what they're doing, they're using these restrictions in their program. Yeah.
Could we tell that it was just negative pi over 6 based off of what we got from positive 1/2?
Oh, just because the sign changes.
Yeah.
No. You will see later, Good that you noticed that. Okay, next, number 4. Let's try one more. Inverse sine 0. Now, it may not exist, but first let me check and see, have I met the restriction on the domain, the number inside, that's the x. I place a 0. Does 0 fall between -1 and 1? So that says there's an answer. Now that answer, when you finally give it to me, has to fall here. Hey guys, does anyone think they know an angle on the unit circle that you've worked with before, that the y coordinate is 0? What size angle is it? Is it pi? Okay, now hang on. Marina, if I say pi, I remember the unit circle. I think the ordered pair there at pi was, what was it, -1, 0? Is that the ordered pair corresponding to pi? And I looked at sine, and sine is the y coordinate, and I agree 100% it is 0, right? And you say, Professor, I think it's 0. Now, I'll accept that, pi, for an answer, right here, pi, if it fits here. Does 180 fall between -90 and a +90? That's the most aggravating part about these inverses. You'll put down an answer that seems like it should work, pi seems like it should work, but it does not fit the restriction. So after all that thought there, I can't use it. And I will tell you, there is an answer.
0 or 2 pi.
All right, tell me again, just 0?
Or 2 pi.
Okay, hang on, let me try 0 first. In other words, you're saying 0, you're saying back here, where's my graph? All the way back here. 0. Now guys, at 0 on the unit circle, I think the ordered pair was, help me, 1, 0. And this is sine 0, which is the y coordinate. That's where it went, right? And does that 0, I know it looks strange, does that answer of 0 fall between -90 and a +90? You line up -90, +90 with 0 fall between. As long as it falls between, I'll accept it. Now, I heard, hang on,
2 pi.
exactly. 2 pi. Just wait, Professor, 2 pi was on the, what was it, 1, 0? And that 0 comes up again for the y, which is sine, and this is what this means to do. 2 pi, guys, that's 360 degrees. Thank you. It does not fit between these two. So they have guaranteed with these restrictions you will get one answer. You may get others that look like they should work, but by restriction, there's only one. To make it 1-to-1, there's only one answer, and you have to decide which one. 2 pi works, but not by restriction. Your pi works, can't accept it by restriction. Isn't that strange? Now the last one here. I said that was the last one. Let's try one more. Let's try inverse sine 2. Immediately, you'd say, Professor, this one has no answer. Why not? The domain, you can only use these numbers called between -1 and a +1. You're way outside that domain. You're at 2. 2's not inside that. -1 and 1, so this one has no solution. Will not work. And that's the problem. That's the problem. Now, Philip, I did all my discussion right now with only one trig function. I did sine. You know there's 5 other trig functions. We're supposed to find the inverse of all of them. I haven't done inverse cosine yet. And guess what inverse cosine is going to do? It's going to have different restrictions. Inverse tan, maybe a different restriction. Now, since I'm limited on time, I will not, it's in your textbook though, I will not mention inverse secant or inverse cosecant, or inverse cotangent. We'll save those three for you, and you can quickly find them as a reference in a textbook or whatever, if you need them. I'm gonna do the principal one, so it's sine. So I'm gonna do the next one is cosine. Guys, that's making sense? So when you see your exam, let's say, I guess your exam is on what, Friday? You know what, how far in chapter 5 did I stay there for the review? Was it all chapter 5? Oh, on the test Friday, up to 5.3. Ah, you guys are locked out on this one. This is chapter 6. You won't see this until the final exam. Oh, my goodness. Oh, my goodness. You'll see it. You won't see it until the final exam. That's all I hang with that, yes.
Will the piece of inverse, will sine always be restricted between negative, pi over 2 to pi over 2, or can that be?
June, thank you. This is set in stone. I don't care where you go, to USC, UCLA, Dartmouth, NYU, stays the same. Stays the same. Does not change. Okay, good question, does not change. Now, the next one coming up, we'll do inverse cosine, and mention inverse tan, and we'll move on some items here. Guys, this one coming up, beautiful question. The one coming up also is going to be set in stone, you can't change it. The next one is this one, f of x is equal to cosine x. We sketch cosine, a reminder. Cosine graph. And my critical numbers, I'm going to know those by now. Guys, we'll graph this in red. One that I need here, -1 here. Please, someone remind me, at the very beginning at 0, where was my cosine graph? Where did it start? Thank you, at the 1. Drop down to the axis, 0. Down here it drops to a -1. Back to the axis. Back here. Connected, or something like this. Of course, you can go on more cycles, so that's enough right there. Now this represents cosine. The cosine graph that we've already done. Now underneath here though, I want to find this. I want to find that. Like I found the inverse sine next door there. What's the issue? It's not 1-to-1. That graph did not pass the horizontal lines yet. Marina, what did those smart people do for us? They made it 1-to-1. Now you can't just go out there and make it 1-to-1 yourself. They've already done it for me. It's already been published worldwide. Can't change it. What do they do for this one? Yeah, look at this. Look at that little slice here for cosine. Worldwide, not going to change. That little slice here for the one we just finished up sine, not going to change. No matter where you go to school. Now guys, I know this is, but it will help us. I know this is 0, 1 for coordinates if I need it. And I think this is what, pi and what, -1 for coordinates. Is that true? Okay. By the way, Philip, if I look at what I just did on cosine, I'm going to list the domain and the range here shortly. And might the domain and the range on this one differ than the domain and range on this one? That's the problem. You have to memorize all of them. And I'm only solely responsible for the 3 major ones. Sine, cosine, tangent. So guys, let's do this. Let's find inverse cosine, says find it. On the side here though, first, that me mention the domain and the range on this one. Guys, the domain, not here first, too fast here. Let's list the domain and the range on the red slice up here first, on this. Guys, what would you say the domain on the red is? From what to what on the x-axis? 0 to pi, inclusive. And the range on the red, y's, -1 up to 1. Now jump down to the black, now I'm discussing the inverse of cosine. Domain and range should interchange. Now the domain becomes what?
Range.
-1 to 1, the range. That's what inverse does, it interchanges everything. And the range changes into the domain, which is what, 0 to pi? And there we have it. Woo. Down the side here, a few examples. Find this first. Inverse cosine, like that, 1/2. And by the way, the domain, inside here I place 1/2, am I allowed to place a 1/2 if I wish? Yes, it's caught between -1 and the +1. So there should be an answer. Now the answer you give me has got to fall here. Between 0 and 180. Does anyone recall from the unit circle somewhere you saw x, the cosine, equal to a 1/2? Here we go. Pi over 3, like 60 degrees. Let's see. Rita says she thinks it's pi over 3. You guys agree? Was that pi over 3, 60 degrees, or was that cosine, the x coordinate, 1/2 for that? Now, I'll accept her answer if I'm doing 60 in degrees. Does 60 fall between 0 and 180? You got it. That's the answer. Number 2. Now, inverse cosine, we do this. -1/2. You better than that unit circle. Okay, now hang on. So if you say, hang on first though. I heard -6, I'm gonna consider that. So first, is that -1/2 for the domain, the x, placed inside there, is that okay to be used? Does it fit here? Does -1/2 fall between -1 and a +1?
Yes.
So there should be an answer. Now I heard, I'm gonna accept what you said there. What you said, give me the answer you thought it was. How much? Okay, because you saw me do something with the negative over there. Hang on now. Negative pi over 3, in other words, -60. Hang on. Now is that -60? Hang on. Would that fall between 0 and 180? See, this one has no negatives in it. Right? By restriction, there are no negative answers on this. I cannot use that. Does anyone have an idea of another possibility?
2 pi over 3.
Oh, our 2 pi over 3. That's 120 degrees. And 120 degrees definitely would fall between 0 and 180. And that's the answer. As long as you make it fit there, we're good. Now, are there other possibilities out there that might work? Yes. But by restriction, there's only one that they want. And you gotta find that one. Oh boy. Number 3. That's right, inverse cosine, here goes. Negative radical 2 over 2. Just get used to this. Here we go.
135 degrees.
Beautiful. I'll check, I'll see if that works now. He's telling me, Professor, 135, let's put it in radians, wasn't it?
3 pi.
It is. 3 pi over 4?
Yes.
Now, that's 135 degrees. Let's see if I can accept it. First, can I accept the number I placed inside? That's a strange number. Radical 2 divided by 2. If I approximate it, do you think it'll fall between -1 and +1? I think it will, so I can use it. So there's an answer, and we think it's 3, 5, or 4? 135 degrees. 100 degrees. Does 135 degrees fall between 0 and 180? Got it. It's done. No question about these restrictions. So if you find it to fit there, we're good.
Is cosine of inverse is even function because when we're counting degrees, it's 180 minus 25, so we're taking that 180 is going to be.
And you think about it, because it's an even function, we discussed it, yeah, you could bring in that. Think about it, yeah. But I'm just saying, be careful, whatever you give me here, that better fit here. Okay, number 4. Inverse cosine, let's try another one here. Oh, my goodness. Pi. Pi is a number, roughly 3.14. I want the inverse cosine on that. Is there a problem?
It doesn't fit in the domain.
There's a domain. 3.14 does not fall here. If it doesn't fall here at the very initial, that's the domain. Yeah, no solution. No solution. Guys, sort of get the drift of what's going on here? You haven't seen anything yet. I know I just have one more trig function, but wait till you see when they start mixing things on you. So put an inverse sine with an inverse cosine. You say, oh my goodness, Professor, both of them in the same problem? We've got to be careful. Something like that going on. Guys, any concerns here? Now, some of my students will leave me, and they'll go to the Math 7, and my colleagues and I will talk, and they'll say, Randy, did you not show the students what inverse sine graph looks like? Not yet. Is this the inverse sine graph? This is the, this is cosine. Is this the inverse cosine graph in red here? No, this is the old cosine graph. We just took part of it off. This over here, this red slice is cute. Does that represent the graph of inverse sine? No. That's just a slice of the regular sine graph. Now, what would I have to do if I want to, and I'm not going to do it today, I'll probably give it to you on the handout. What might you have to do to really see what the graph of inverse, let's say, sine, or cosine, let's do cosine. What might you do there as a clever student? Say, wait now, I know how to get the graph myself. I know how to get a sketch of inverse sine, not sine, inverse sine. Go for it.
Rotate it on its side.
Rotate something, okay. Here we go. She's looks at all these graphs in her mind, says, I'm gonna revolve this thing around and rotate it, and that's what they'll do in, I think it's Math 11. No, something else, a bit easier. What might you do, and which may involve the rotating? What might you do here to at least get a glimpse of what the inverse cosine graph in this case might look like? Phil?
Would you reflect it over 1 equals x?
Hang on. You're saying if I put this in, this is y is equal to x. And somehow do a reflection of that red graph across that line. I know it's not as easy as the reflection through the x-axis, reflection through the y-axis. But if you're clever, he wants me to reflect this piece over that line, and then this piece over that line. And if you can visualize that in your mind, some students do, they can see what the graph looks like. Now, why did you choose y is equal to x? Why not just the x-axis, y-axis? Why is it y equal to x? Yeah, what about that? Why choose y is equal to x? Why didn't you say draw Professor y is equal to 2x? And reflect. Why did you say y is equal to x? Which is true. But why? I did some erasing. I think back when I asked you to start mentioning things you recall about an inverse, I think someone said, Professor, when you do this, I think I called it a check. What are you supposed to get? Guess what? That's the x. It says y is equal to x. There's your reflecting line for a function with its inverse. Now, Philip, I'm standing here right off the board. I don't know if you want to step up and show us what you think what you think the red graph looks like reflected across that line. Not the x-axis. The x-axis is easy to reflect across. Y-axis is easy. We don't know. But to reflect this red graph, this piece here on the top down goes somewhere on the bottom of that line. And this piece, I guess he's telling me, well, it goes up here somewhere. Does anyone think they visualize it? Joseph, you say you do. Come on up. 'Cause I'm on top of the board, I can't see it. Guys, do me a favor, put in this color here so we can see it. Show us what you think the inverse sine, cosine graph looks like. I reflect it. Yeah, use that.
On this one.
Yeah, yeah.
This would be 1 instead of 5.
Let me show you the full graph.
Oh, okay.
I want to see the full graph of what you think inverse cosine looks like. Not reflecting that graph.
Probably not.
You guys think you agree? Oh, I see that hesitation, like, whoa, Joseph, what did you do here? Joseph, are you telling me this point right here is now labeled as -1 pi? Hang on. On my graph here, on my red graph, it was pi -1, wasn't it, right? Right here? Oh, I got it right here in front of me. Is that pi -1? Does his graph now have that interchange? And I noticed another point he gave me, he says, Professor, I think, Joseph, remind me, did you stop there, right here?
Yeah.
What do you need, what's that point?
It's
1?
Yeah.
And what, 0?
Yeah.
And did I have on the red 0, 1? Did he have it interchanged? Wow. And by the way, right here, I think he labeled this as what? Pi over, was that pi over 2? What was this? What was this guy? I had, this point right here was what? Pi over 2, 0. Does he have now 0 pi over 2 represented here? Is that what he's talking about? Did I have pi over 2, 0, now it's interchanged? Oh, thank you. Gee. So you can actually draw these yourself. And you could do the same thing he did. Bring in there and do this over here. Show me the inverse sine graph. But it's interchanging. You guys agree? Yes.
Is there a way to graph the inverse on the original graph, because now the scale is different, and so you can't.
Exactly, you may have to change this, you may just change the, I think that's what he was gonna do at first, he saw that maybe the scale was off a little bit or something. I think he was gonna put it on here. I'm glad he did it separately, yeah. Do it separately.
Is there a way to?
There's a way, but she has to play around with it and make it fit. Make sense, guys? And that's 3 of them out of the way. I'm gonna do, maybe, I got 5 more minutes to do what I gotta do on this part. Now for a break, I saw all students look at that clock, oh, get a break. Ooh. 5 more minutes to finish this out. It's done. Inverse sine, inverse cosine. Now I'm interested in showing what all this means for us. After I finish up here. So you guys, all that's done. Now the last one is, yes, I'm going to inverse tan. Okay, side here, let's call this, letter C. F of X. Last one. And a little quick reminder of what that graph looks like, tangent. For a parent graph. Please remind me, I think we accepted in class, the part between negative pi over 2 out to positive pi over 2. And I think we had an asymptote, if you guys can remember, at negative pi over 2, which is the tan graph, pi over 2. And please tell me, if my memory serves me right here, it looks something like this. Yes or no? That's what we accept out. I think it's a parent graph of tangent. So this y is equal to tan x. Now, of course, what we want to do is, we go in red. I'll write this one in black, I did backwards. That's okay. Let's do in red here. They want us to find the inverse of this. Okay. There's my just regular tan graph. And they want the inverse of it. Anyone in class tell me how have we lucked out here on this one?
Domain and range.
Something else. We'll get the domain and range, but how have we lucked out on this one? It's 1-to-1 right now. Would it pass the horizontal line test right now? Therefore, there's no need for me to go over here and wipe something off and say, now the committee says, wipe this off. No, this is it. It's like it is, it's 1-to-1 right now. The domain on this tan graph, guys, from left to right, please tell me, with a negative pi over 2 over the positive pi over 2. And the range was negative infinity through positive infinity, yes or no? Now, tell me down here on the red, what was the domain on the inverse tan and range on the inverse tan be? How about the domain first? Negative infinity through positive infinity. Interchange. And the range, of course, should correspond with that domain, which is this. Okay, now we'll just try a few examples. We'll jump in and see what we do. Guys, on the side here, if you were asked to find, let's say in red here, find inverse tan, here goes 1. Sabrina, I placed inside here 1, that's my domain, that's my x. The domain says I may replace anything as long as it fits this. Does 1 definitely fit this? Also, on this one, I get to place any number I wish. So negative infinity to a positive infinity. And you guarantee you're gonna get an answer. On the last two, I had to be careful. This one is open. So it should have an answer coming out then, definitely, and the answer must fall between negative 90 and a positive 90. Now, where on the unit circle have you seen tan, y over x, equal to a 1? So again, 5 to 4, 45 degrees. Makes y over x, you get a 1. I think both the coordinates were radical 2 over 2. What is it? Radical 2 over 2, radical 2 over 2. You get a 1. Place y over x. Does 45 degrees fall between negative 90 and a positive 90? Yes. So I would accept it. Next one. Inverse tan. Thank you on that one. Negative 1. Keep in mind, guys, I like inverse tan because it's open. I may put anything I wish in here. It's open. And you're guaranteed an answer. Okay, inverse tan negative 1, y over x. Can someone give me an answer on the unit circle where when you place y over x, you get negative 1? And then I'll see if it fits this down here.
Negative 5 over
Okay, now hang on. Negative pi over 4. You're down in quadrant 4.
4. I mean,
Negative, hang on, I'll check. Hang on. Let me show quickly in a sketch right quickly. He's telling me, Professor, it's down here. This is negative 45 degrees. Or negative pi over 4. If it is, here goes. I need the coordinates. And I think the coordinates for this would be in quadrant 4 from middle school. I think it's a radical 2 over 2 for sure, right?
yes.
And then is it negative? Radical 2 over 2 for the y.
Yes.
If you place the y with the x, do you get negative 1?
I think
If you do, I'm done. You get negative 1. If you place this over this, wouldn't everything cancel?
yes.
You get a negative 1, and I'm looking for a negative 1. He says negative 5 over 4. It works. And by the way, does negative 45 fall between these two?
Yeah.
Between negative 90 and a positive 90, negative 45 falls in between. Thank you. Now I've had students in the past say this. They'll say, Professor, I'm looking at my unit circle. They usually have their unit circle right in front of them. And they say, Professor, I think it's this. Seven pi over 4, which I think is 315 degrees. They're thinking about this. Which stops the same place his does. And it has the same coordinates. If you put this over this, y over x for tangent, you get the negative 1 you need. What's wrong with saying it's 7 pi over 4, which is like 315 degrees? Why can I not say, no, Professor, I think he's wrong. I'm going to put this. Which works.
It doesn't fit
It does not fall here. It does not fall between negative 90 and a positive 90. 315 degrees is way outside. So even though it works, can't use it, I must accept what he gave me. And that's what's going on here. Okay, here goes. One more. I think you guys are seeing now what's going on. I'm gonna try this. Inverse tan of this. 50. Should it exist? I put 50 inside there. What can I place inside there? This is domain. This is the x. I put 50. Does 50 fit this?
Yes.
Yeah, it says all real numbers, negative infinity through positive infinity. Now, have you seen a 50 with our work we've been doing in class? Of course not. Is there an answer for this? Yes. Mr. Park, he's busy. I was going to ask him about use a calculator or find it. Inverse tan 50. We'll get, if you try it on a calculator, who has a calculator handy? A phone or something there. Find inverse tan 50. Do it in degrees, so see what size it is. No, it says it's out there. There's an answer. Would I dare ask you this on a test? No. I'm just showing it, there's an answer though. Inverse tan 50. Oh, you got it already?
No, I just have.
Yeah, hang on till I get that 50. Who had it? Inverse tan 50. It's gotta be an answer. And I want it in degrees if possible. Alina?
1.5.
Okay, is that in radians, 1 point something?
Yeah.
Can you change that to degrees for me?
I don't know how.
Okay, I bet that 1 point something is in radians. Let me see if someone has it in degrees. I'd like to just see what size angle it is in degrees.
88.8.
88.8. This is an approximate answer, guys. Wow,
It's getting closer to mine.
it is. Now, I heard from a student, inverse tan 50 does exist, you have to just calculate it. And I hear it's in degrees close to what, 88.8 degrees, so it does exist. I wouldn't, of course I couldn't ask you to do that on a test, I'm just showing it does exist. Okay, Alina, your 1 point something also made work, which you converted to degrees. Okay. Oh, you did?
Yeah.
And you got so close to what? Good. I'll say. I thought so. Alina, Arena,
How we can find the development?
you can't. You can't, that's what I'm saying, I couldn't dare ask you to find that. You can't do it unless you go to a calculator.
But they had some formulas.
Oh, there's some formulas, guys, but not for this. There's some formulas coming up in trig that will allow you to find, like, something with 15 degrees, where 15 degrees is not listed on the unit circle. There's gotta be a special angle.
The formula that they put into calculator.
Oh, my goodness, you're asking, there you go. She wants to know the program that was programmed into all these beautiful calculators that somebody programmed it, Professor, and I want to know the program, right? Give me the program. So I'll know what they were doing, if you just have a program. She's been using, AI. And she's been having, she said, Professor, sometimes I'll ask to have something done, right? And then she'll respond, I think she told me, she said, she got an answer to come out through AI, and she can ask what? Are you sure?
Yeah,
She asked AI, are you sure? And how did AI respond?
I'm sure.
I'm sure. And AI was wrong. Yeah, talking to AI, and AI's going to tell you, I'm sure, that's the answer. Accept it, and find out the answer is not there, right? She said she's paying a little bit of money for that. I said, no, don't pay any more money. No. Okay, guys, we're okay here? Now, I'm not doing inverse secant, inverse cosecant, inverse cotangent. They have these also. I think for my class, you have enough to worry about for these restrictions on the primary trig functions, okay? That's all that said though. I gotta watch here. Part 2 maybe? Yeah, look at your handout. Goodness sakes. Did I have some problems there at work with the inverses? You see. We'll get this out of the way fairly quickly. Guys, I see some that are just straightforward. Let's go through these right now, see if we can get these out of the way. Inverse sine 1/2. Looks like this, guys. Section 6.1 and 6.2. You have the handout. I hope. Okay? So what have you filled in the blank there for inverse sine 1/2? Uh-oh. 5 or 6. Discuss these. Number 2 says inverse cosine negative radical 2 over 2. I think I did that. I raised it probably. Does anyone recall what that was for negative radical 2 over 2 inverse cosine?
3 pi over 4.
Thank you. Put a 3 pi over 4 in there. Next one is this, guys. I'm gonna get this out of the way. Inverse tan. Here goes. What you want to see when you finally see all this on the exam. These types. Inverse tan, and I gave you this. Now this one's tough. And since inverse tan, yeah, staring at me here, there's my domain. My domain's open. So if I want to put a negative radical 3 over 3 in there, go for it. That means there must be an answer. But the answer's got to fall between these two. Negative 90 and positive 90. Does anyone recall y over x, somewhere on that unit circle, will give you radical 3 over 3 to begin with? Then we'll consider the negative. Okay. When you place the y over the x, you simplify it, you get radical 3 over 3. It's on that unit circle somewhere. I can't get off that unit circle on the test. It's on there somewhere. What is it? Some students will say, Professor, I remember pi over 6 had this as ordered pairs here. Guys, help me out here. What was it?
Radical 3 over 2.
And
1 over 2.
1/2. Maybe it's that one. Well, let's place y over x there and see if it is. I'll place y over x, you're placing this over this. These cancel. If I simplify that, would that take me to that? Now, except this one has a negative sign in front, so you can make things more complicated. But it has something to do with 30 degrees, 5 or 6. Now, does anyone think they know by restriction?
Just
Paul?
divide by the quadrant 2 or quadrant 4, because it's negative 10.
Okay, tan is negative,
Yes.
and tan is negative, I heard you say tan is negative what, quadrant 2 and quadrant 4. Okay, at 4, Philip, if it's 4, do this, look at all the things we do. It's down here somewhere, quadrant 4, and I know it has something to do with 30 degrees, so it's down here. And a little negative sign to show I'm down there. Best expressed as,
Negative pi over 6.
thank you. Get my answer. And that does fall between these two. Negative 30 falls between negative 90 and positive 90. Okay. Next one, I'll get your paper back to you in a second. The inverse cosine 2, guys, go ahead and put no solution. Number 4 is no solution. And then inverse 10, I don't know why I threw in inverse 10 4/5. Are you kidding? Hang on, I know the reason I more than likely did it is this. Last one on your handout has that. And the domain on inverse 10 is open. You may place anything in there, like I placed, I think, a 50. 4, 5, or 5? You have to use a calculator for sure. Right? Someone doesn't have to go to AI or use a calculator to find it.
Second
Oh, I'm not worried about, yeah, but, you're asking, look at this. You're asking for inverse 10 on that, you just have to approximate this thing, 4 times 3.14 divided by 5, and get some type of decimal, and it's not on the unit circle. This will, it has an answer, but I bet if I ask someone to do it, you're gonna get some strange answer that we're not accustomed to, but there is an answer. But I'm not gonna worry about that. There's an answer out there. Okay, Lena, help me out with the last one there with that 50. Okay, guys, I just threw that in to show I would not ask something like that. Okay, next part there says, now, Lena, read to me, and we're going to close down this. Let's see how much we really, really know about all this. Like, I'm going to put it over here on the side. And watch carefully.
You want the
Hang on,
find
hang on.
the exact value?
Yeah, the part down at the bottom. Hang on. Where it says, I think, what, find the value?
Exact value.
Exact value. Guys, I'm very proud of you. Before I get jump into this, some of those classes are, I've talked to my colleagues, some classes are down to 4 students. I think one class has 1. Are you kidding? This class has got a good one over here, and good grades. What was the first one there, Stephen?
Sinus.
Sine?
Sine of cosine of inverse 1/2.
Like this. Okay. There you go. They're now doing a composite. They're putting two things together. Someone be clever for me in this class and tell me, how might you, let's say the first time you've ever seen this, how might you approach this to get an answer?
So first you do the inside one.
Thank you. Now there's that inverse cosine. I don't know whether I still have inverse cosine on here somewhere. Oh, I do. I do. So inverse cosine 1/2 says, and 1/2 fits here, so that means there is an answer. And the answer's gotta fall between 0 and pi. Now, I think that's one that you can find on the unit circle. Does anyone think they realize what angle it is whose x coordinate is 1/2? So what is it?
I over 3.
I heard pi over 3. 60 degrees for the inside part. You check out the unit circle, I think, is the x coordinate short enough 1/2? The cosine? And the 60 degrees of the 2 exactly fits this. We're good. Now to finish it up, watch carefully. Now to say, don't stop there. Do that to it. Now what's the sine of 60 degrees?
Radical
Is it, I heard 1/2, then I heard radical 3 over 2, sine of 60 degrees. Is it radical 3 over 2?
Yes.
The unit circle? And there's your final answer. Doing 2 concepts in one problem. Rita, what's the next one?
Secant of tangent,
Oh, hang on, secant of inverse tan,
inverse tan, radical
radical 2,
3.
oh, 3. Okay. Like that. Guys, now, I know what's happening on that handout shortly. Can anyone recall where on the unit circle, if possible, an angle that when you place y over x, you get radical 3? I'm hearing pi over 3. Hang on now. Now, if that's pi over 3, 60 degrees, a little reminder, DK gave that to me. Pi over 3 had for coordinates, if I'm right, was it 1/2? Radical 3 over 2. Were those the coordinates at pi over 3?
Yes, yes.
And if I place y over x, that's what tan is, if I place y over x, this is the y, with what she gave me, over the x, these cancel. Does that give me radical 3? She's chosen the right angle on that unit circle. It is pi over 3. Now what do they want? They want secant of that. And secant's definition is what? 1 over x. And what was the x? 1/2, wasn't it? Was it 1/2? Is it? Is it 1/2? So it's 1 over 1/2, 1 over x, is the definition for secant, which comes out to be what? 2. And there's the answer. You like these? Makes you reflect back to the unit circle, and also we're doing the inverse with this. Rita? What was next one?
Tangent of inverse sine, 1 over 3.
1 over 3?
Yes.
Oh, Joseph, I think I made a mistake. I created this handout. Are you sure I said 1 over 3? No, 1 over 2. Oh, I made a mistake. First, put aside your inverse sine 1/3. I'm using 1/3. I think the inverse sine discussion, I think I may have erased that one. Is it okay for the 1/3 to be used? Was it the domain was caught between what? -1 and +1, so 1/3 is okay. That means there's an answer. But it's not one that you can find on the unit circle. Has anyone ever seen 1/3 on the unit circle? Nor will you ever. But does it exist? Yes. Now, there's the professor. Suppose I don't have a calculator. And on the exam, I start crying. You look at me and you say, oh, what am I crying about? I didn't bring my calculator. Where am I using calculators? You said, wait, how am I going to do this problem? Ah. Inverse sine 1/3 is what I wanted. I didn't want 1/2. I want something off that unit circle. And guys, watch carefully. This means there's an angle out there whose sine is 1/3. I'm standing here as an instructor. I have no idea what that angle is myself. But it does exist. All I know at this point as an instructor, and you, it's not 30, it's not 45, it's not 60, it's not 90, it's not 180, it's not one of those on my unit circle. But it exists. I just use a calculator myself to find the real size of it. But without finding the size, let's try to come up with a way to get this. Gia, they're asking me after I come up with this, maybe to find tan of it. Oh my goodness, someone will be clever to close this down pretty soon and tell me some creative. I've got some creative minds in here. Can someone be creative and tell me, you have no calculator in front of you. I'll tell you ahead of time, you really don't need the size of the angle. You don't need a calculator. There's something else going on that connects with something we did before.
Can I just say that tan is sine divided by cosine?
I love that. Sine over cosine is tangent. Oh, you're almost to where I want to go. Give me more. Give me more. You're stuck. You're staring at it. You say, oh, you made a mistake. You should have fixed one half.
Y over x.
Y over x is tangent. All I know right now is sine is 1/3. Too bad it's not 1/2. I could have gotten the answer quickly. The unit circle. Okay, guys, here it goes. Watch carefully. I'll step out of the way here. You have no calculator. Does anyone remember this identity? Remember sine squared plus cosine squared is equal to 1? Suppose I say, wait now, sine's 1/3. So why not replace sine with 1/3 here? It's being squared. Plus cosine squared is equal to 1. And solve for cosine.
So 1/3.
Yeah, so what's that, 1/9? Gotta move that 1/9 over, subtract it. Guys, you're going to solve an equation. This is cosine squared. It's equal to 1 subtract 1/9. That's at 1/3 squared, which is 8/9. 8/9. Take a square root. At this point, it's plus minus. Now, square root, and I know some of my students on that last test, I think I had a square root something, I don't know, maybe an 8 involved something.
Just two.
Remember that last test, and some students broke it down wrong? What's square root 8 on top? It's not perfect. 2 radical 2. Got that? Of course, square root 9 is beautiful. It's 3. Gee. Now I know what cosine is. Now I heard students say, wait, Professor, tangent is what? Sine over cosine, isn't it? Y over x. I heard y over x. So wait. So all this, look at this beautiful math. Absolutely beautiful. On the side here, yes, tangent, which you're asking me to find, is equal to sine over cosine. June, I may ask you if you have a calculator handy or maybe some device and check something over here shortly. Tan is sine over cosine. Guys, sine was given to me. It's 1/3. But 1/3. Cosine looks like, I'm going to use the policy for right now. Cosine we just found to be a 2 radical 2 over 3. Strange numbers, but that's what we got. Everyone agree? Sine over cosine, tangent, no calculator being used. 3's cancel. If I want to clean this up, rationalize. Is it radical 2 over 4? Being cleaned up. I did that quickly. Let's step back and look at it. Is it, guys? Is it radical 2 over 4?
Yes.
Woo! Am I saying at this point that this answer here is that?
Yes.
Joseph, I noticed here, I was a little careful. When I took the square root, because I saw that square there, I put plus or minus. And you'll probably say, Professor, why did you choose the plus 2 radical 2 over 3 when you put that in here? Why didn't you choose the negative? Joseph, can you give the class a reason why maybe I have chosen the positive and not the negative? Now, just think about it. Why would I not use the negative in this case? I chose the positive. I think that's the answer. some students may think I should use the negative. And have a negative answer. You wanna have a rationale why?
Zero.
Does anyone think they know which quadrant we're talking about here? Not necessarily the size of the angle, I don't know the angle myself. Do you know, which
First
quadrant this might be? Now, by the way, this says there's an angle out there whose sine is 1/3. What this means? Sine is 1/3. Does that help you try to locate which quadrant of the four might I consider if sine is positive 1/3?
One.
Quadrant one, is it also, sine the y coordinate positive in quadrant two?
Yeah.
Okay, now, have this consideration, it's either here or it's here.
But tan is positive only in first and third quadrant.
Okay, and I'm doing, inverse sine on that. Didn't the inverse have a restriction? Inverse sine 1/3, what's the restriction on inverse sine? Called between negative pi over 2 and what? Positive pi over 2 was it earlier? So you've got to know these restrictions. If I'm caught between negative pi over 2 and a positive pi over 2, which quadrants am I considering if I'm caught? Look at this. Here's negative pi over 2, here's positive pi over 2. Am I caught in there somewhere? Between negative pi over 2 and a positive pi over 2, does that mean I'm either in quadrant 1 or quadrant 4?
Yes.
Okay, now which of these would be in quadrant 1 or quadrant 4? Guys, where was it here? Quadrant 2 is out there. I should be in either 1 or 4.
It's one.
So that's out, so I'm in 1. I can't consider quadrant 2 by restriction. June, we're gonna close down here shortly. I know that, I see students' looks right now. They're saying, whoa, professor, it's getting tougher now. June, do me a favor. Would you please first do inverse sine on 1/3 in degrees and tell me what size angle is it? Because I have no idea what it is myself.
It's 19.47.
19.47.
In,
Hang on.
in degrees, right?
19.47. Now take tan of that. You meet me in the hallway and ask me to do that problem? No way.
It's 0.3535.
0.3535?
Mm-hmm.
And she's telling me Professor tan of that strange 19.47 is 0.3535. We have this. Right answer. See what radical 2 divided by 4 is.
It's also 0.3535.
So we approximate radical 2 over 4, she said, Professor, it's another 0.3535. Oh my goodness. Arena. Gia. PK. Don't stop me in the hallway and say, Professor, what's inverse sine 1/3? No. I don't have a clue. I don't have a clue. She had to give that to me. Okay, does it work? She checked it and it works. Now, I see that it's almost within minutes here, it should be, what, break time? You guys get a sense of how involved this can get? It can get crazy on you. That's why I got to finish up this handout after we get back on the break and then move on to something else. Are you guys enjoying Math 2?
Yes.
Look at those faces. I mean, look at those faces. Are we enjoying Math 2? I think so. I'm enjoying it. Okay, guys, take your well-deserved. I'll see you at 2:15. Well-deserved 15-minute break. Marina, do I still have your paper or is that, can I get that back to you?
I'm getting depression.
You know, just enjoy one of these days, maybe create a computer program for us. Right, in math? And publish the book. We'll start using, Joseph, here. Sabrina, they do have all these programs. You can see what that program looks like. I'm sure it takes pages, pages of programs
Yeah.
to do it. But they exist.
Yeah, why I asked, because when I raised my hand, you said you had the answer, and I was like, maybe I can't make my answer like on the list, on the paper by myself.
Oh,
without calculating.
right.
And I was
Oh, on this one?
confused. Yeah, when you said what is 15, tangent of 15.
Oh, yeah.
And you said, oh, you have answer, I thought. maybe
Oh, I
could-
got you. You said,
yeah.
is there some way I could have done this myself?
Yes, yes.
Exactly. I'm sure there's a formula out there somewhere. But we're gonna hold you responsible for just certain formulas.
And I'm not using AI, so thank you very much.
Okay.
Professor, can I see what was my mistake, on that, extra?
I'm gonna let you pick it up as you leave.
Oh,
Now, he scored these, Mr. Park did.
yeah,
I haven't looked at them.
okay.
Okay, we'll see. Because I think you got 5 out of 6, right?
Yes.
Yeah, we'll see.